In today's class, we discuss about quartiles, box plots, and percentiles. So let's get started with the quartile. A quartile is basically a statistical term that describes the division of data into four defined intervals based on the actual values of the data and how they are compared to the entire set of observation. Basically, we are dividing data into four equal intervals. That's the word quartile itself states, and it measures the spread of data above and below the median by distributing into four equal groups. Okay, so first of all, when you see a question regarding a quartile, you need to arrange the data in an ascending order. So first of all, we arrange the data in an ascending order. And for division into four equal parts, there are 3 points which are first quartile, also known as lower quartile, and is usually represented by Q1. Second one is median, which is known as second quartile as well, and presented by symbol Q2. And the last one is third quartile. This is also known as the upper quartile and presented by a symbol usually by Q3. So if I just try to visualize the data, so first of all, if I divide the data into equal parts, if total is 100% and this is median, which is dividing data into equal parts 50% on both sides. So we have 50% data on this side and 50% of data on this side, and representing median by Q2. Now what is first quartile? First quartile is actually the median of the lower 50% of the data. So if this is lower 50% of the data, so what will be the median? Median will divide that into 25% each. 25% on this side and 25% on this side. So this is the lower quartile or first quartile. It's presented by a symbol Q1. And there is 25% of data, 25% of the data. Likewise, on the upper 50% of the data, there is the upper quartile Q3 that divides the data into equal parts, which is 25% on this side and 25% on this side, and this is Q3. Now just a quick revisor that if we ask to find the median, so there could be two scenarios: if total number of elements are odd, or if total number of elements are even. If total number of elements are odd, in that scenario, for example, if n is equal to 5, so to quickly find the median term, just add 1 in this and divide by 2. So that will be 6 by 2, which is third. So third term will be the median term based I've already arranged the data in an order. And when the question says that total number of elements are even, for example, if n is equal to 6, the median will be just the average of middle two terms. That will be, if this is 6, that will be third term and fourth term. Just take the average of these two terms, so whatever the value, that will be your median value. Okay, so to get an idea, let's consider two small data sets. In one, the number of elements are odd, and in other, number of elements are even. For example, considering the number of elements odd, and if I consider data set having elements 1, 3, 5, 7, 9, 11, 13. So in total there are 7 elements. So what will be the median? Median will be, just add 1 in the total term, that will be 8. 8 divided by 2, that will be 4. So fourth term will be the median term, which is 7, and this is already arranged in order, right? So that's why the median is 7. Now just see, this is 7, which is median. Below there are 3 terms, 1, 3 and 5, and above these are also 3 terms, 9, 11 and 13. So if I want to find the median of the least 50%, so what will be that? Because total there are 3 elements, the median will just the middle value, that is 3. So the lower quartile Q1 will be equal to 3. Likewise, and yeah, this is Q2, which is the median, and the upper quartile, again we have 3 terms, so just take the middle value, which is Q3, and this is the upper quartile 11, and Q2, this is the median. And in comparison, if I just consider the total number of elements as even, in that scenario, for example, if I consider 1, 3, 5, 9, 11 and 13, seven, 9, 11. Okay, so in total now I have 6 number of elements. So what will be the median of this? Median will first arrange this. This is already arranged. So median will be just the average of middle two terms. Those are 5 and 7. So median will be 5 plus 7 divided by 2, which is 6. Now median is 6. We have 3 elements below, 1, 3 and 5, and 3 elements above, 7, 9 and 11. So what is the median of the lower 50% of data? That will be this 3, which is the lower quartile, and this is the median, which is 6, which is Q2, and this is the upper quartile, which is 9. You will be hardly asked about the quartile in this way, but this is just a bit idea about the quartile. Okay, so let's move further. Now let's talk about the interquartile range and interquartile deviation. First of all, let's see what is interquartile range. Range itself states that you need to find the difference between maximum and minimum value. So the question arises, why should we use interquartile range instead of range? So usually they are data set with some extreme values, usually called as outliers. In that scenario, if you want to get an idea about the total data set, it is not wise to just use a range. For example, if I have 1, 2, 3, 4, 5 and 100. Now if I use the range, that means I'm just considering these two, and that is not a overall representative of the data set. So in that scenario, it is better to use interquartile range. So what is interquartile range? That is the difference between the upper quartile and from the lower quartile, which is Q3 minus Q1. So you can straightforward find the upper quartile and the lower quartile, and as a result, you can find the interquartile range. And interquartile deviation has only minute difference, that you are just dividing this interquartile range by 2. So sometimes you can present data set using the interquartile range or using interquartile deviation. So this will be Q3 minus Q1 divided by 2. So now let's talk about the box plot, which is often known as box-and-whisker plot, and sometimes known as a box plot. You will see both of these words in actual exam. So what exactly is a box plot? This is a graphical method of displaying the 5 number summary of a set of data. So you are just displaying graphically the set of data using the 5 number summary. So if I want to represent this, box plot is represented by a box and with 2 extremes on both sides. This is the lower extreme, the minimum value. This is a maximum value, and this thing is the lower quartile Q1. This is upper quartile Q3, and there's a line between, which is the median, which is Q2. So these are 5-point summary, which includes minimum point, lower quartile, median, upper quartile, and the maximum value. So remember one thing, based on this, we are only sure about the exact value of the minimum and maximum. For example, if I just represent this, just to give an idea, that this is a box. Example, this is 2, this is 4, this is 5, this is 6, and this is 7. And if I say that these are the representation of the Q1, Q3, Q2, minimum value and maximum value. So if I say that these are the score representations of 100 students of a class, so what I am sure about that, I'm sure that at least one student got a score of 2, at least one student got a score of 7, but I am not sure that any student got a score of 4, 5, and 6. These are actually the quartiles Q1, median, and Q3, and these depend upon the overall data set. That is not always the point that at least one student got 4, at least one student got 5, or at least one student got 6. So we will have one question relevant to this to get an idea about this. Okay, now let's move further. There is one very important thing to be discussed here. The thing is that someone may ask that we are dividing the data into 4 equal parts, but it is not always the case that the difference between these vertical lines is always same. For example, if this is a case that the difference between the line is same, but there could be scenario something like this. There could be a scenario something like this. So the thing is, The gap between the vertical line representing difference in the actual value, not the total number of values. We are dividing data set based on total number of values, but the gap between the vertical lines it is based on the actual difference between the numbers, not total number of values. For example, we have 12 values, so we divide that into 4 equal parts, right? So there are 4 values, 3 values in each. Now, there could be a point that this include, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, but this include 10, 11 and 100. So if you take the difference, there is a huge difference between. So the only takeaway from this is the gap is based on difference of the actual value, not total number of values, right? And just consider one example for this, and then we'll move to the question portion of this. For example, if I consider a data set having total 12 number of values, and for example that is data set is 1, 2, 3, 4, 6, 6, 7, 12, 14, 15 and 16. So there are 12 values, and these are 50% of data set below the mean, and these are 30% of data set above the mean, and this is already arranged in order, and total number of values are 12. So what will be the median? Median will be the average of middle two terms. So median will be equal to 6. Now for the low quartile, just see the low 50% of data. So just find the median of this. What is the median of this? Add total 6 values, total number are even. So just take the average of middle two terms. So just take the average of these two. So lower quartile will be equal to the average of these two, which is equal to 3. And now see the last 50% of data. So in this data set, to find the median, because the number of values are even, just take the average of middle two. So that will be, in that say Q3 will be equal to 13. Now we know the Q1, Q2 and Q3, and we know the minimum value, which is this, and maximum value. Now we can plot the box, we can just figure out the box plot, and there are some questions in which you are asked to find, in which you are provided with a 5-6 box plot in front of you, and you provide with a data set. You need to find which is the best representation of that. So if, for example, if there is one option like this, so lowest value is 1, maximum value is how much? Maximum value is 16. What is the median? Median is equal to 6. What is lower quartile? That is equal to 3. And what is upper quartile? That is equal to 30. So based on this, we can just quickly pick up the box plot which has all of these 5 points. Now let's discuss the common ways of asking the box plot. So what is the common ways of asking them? The first way is in which we are given the two box plot at the same time, and we are asked to compare, for example, one box plot is something like this, and second box plot is something like this, with the same number 9. So that we need to compare their 5 points, which is minimum, maximum, lower quartile, upper quartile and median, and also the interquartile deviation, interquartile range, and the overall range. This is one type of question which is asked. It's very simple question, straightforward. You can just compare these values based on same number line, and you can find all of those 5 points, and based on those 5 points, you can find the interquartile range as well. So next question is again very simple question in which you have only one box plot, and this will involve the could be case and must be case. Just like I gave you example earlier that, for example, this is 2, 3, 4, 5 and 6. They only showed that minimum is 2 and maximum is 6. But we are not sure that whether there is actual 3, 4, 5 or 6 in that data set, right? Because there could be a case that, for example, if this is 3, this is 5. Just give an example. So we can take because we consider the total number of elements are even. So if I take the average, we get a median 4. So we are not sure that 4 is present in that data set or not. So the only thing we are sure that the minimum value is 2 and the maximum value is 6. Right. So this is second type of data the question which is asked. And the third type of question is in which we are given the data set, just like this is 1, 2, 3, 4, 5 and 6. And we are provided with the 4, 5 box plots. I mean to figure out what is the best representation of this data set, right? And just like these are given 3, 4 box plots, and we just need to figure out what is the best representation for this data set. The fourth one is the inverse of this. We are provided with a box plot, and we need to find the best representation of this. The best representation of this box plot based on 4, 5 options which are provided, right? And the next thing is very interesting, in which we are given data in tabular form, and just like, for example, we are given that we have number of we have some number provided, and we are provided with a frequency or with the relative frequency. And for example, if I consider a case, this is 1, 0, 1, 2, 3, 4, and this is, for example, 0.2, 0.3, 0.1, 0.1 and 0.2. The question could ask that what is the first quartile in this, what is second quartile in this, and what is the third quartile in this. So the thing is, just find the cumulative frequency. So 0.2 for second one, this is 0.5. Now let's make this case a bit simple. Ease our confusion. This is 0.2 and this is 0.24. Now let's see that for 0, the relative frequency is 0.2, and for 1, this is 0.2 again, 0.3, 0.2 and 0.1, and this add up to 1, 2, 4, 6. So what is the cumulative frequency? 0.2 and 0.2 plus 0.2 is 0.4. Now what is the lower quartile? That's separate the lower 25% of data from the upper data set. So actually, what is relative frequency? That is showing 20% of data, 20%, 30%, 20%, 10%. So this 40% means this is a range, right? So the first quartile will be 1, right? So this will be the first quartile. And now let's move further. 0.4, this will become 0.7. Now that means the 50% is lying within this. So this will be the second quartile. And let's move further. 0.7 plus 0. That is 0.9. So 0.75 is lying within this. So this will be a third quartile. And add 1, 0.1 is this will become 1. So 1 is the first quartile. 2 is the second quartile, which is the median. And 3 is the third quartile. So this is another type of question in which we are given the data in this form, either in frequency form or relative frequency form, and you are asked to find the first quartile or second quartile or could be median. Right? And the next type of it is a bit in the hard section, which is in form of what problems. Just like a question we will solve in the practice part, that for example, if there is a class of 100 students and someone is at start 25 standing at a 25th percentile, now 50 students join the class and 25 students are less than having a score less than that person, and 25 are having a score greater than that person. So what will be we are given the earlier quartile, so what will be the new quartile? So this is a bit asking about same thing but in the verbose form, right? So these are a bit idea about the common type of questions about the box plots, which are usually asked in exam, and we will try to see example for some of these. And there is one more type of question in which is based on this concept that this is 0, this is 25th percentile, this is the median of 50th percentile and 75th percentile. So if a question states that is some value, for example, if I say that this is a representation of 800 student scores and this is, for example, 27 and this is at 90th percentile. So we know what is difference between them, and we are asked to find how many scores are in this range of 25 to 27. So based on this concept, we can also find this. So what is difference between them? That is 50. Because what is 90th percentile? That 90% of data set is below this and 75% of data set is below this. So what is difference between them? This will be 15%. So the values lying in this range will be 15% of this 800. So what exactly is a percentile? Is a value below which a certain percentage of data falls. And sometimes this is a very tricky concept. And just to give an idea about this, if I say that a student got a score of 80 out of 90, so this is not giving a clear-cut picture that what is actually meant by 80 scores, unless I know that the 80 scores is lying in which percentile score. For example, this 80 could be 90th percentile, this could be 95th percentile, this could be 20th percentile. So just by knowing this, that person is getting the 80 out of 90, we can't have any clear-cut idea about that. We can't have get a real meaning out of this. There could be a scenario that all of the students got above 80 and this is a student who got 80. There could be a scenario that these only students who got 80 and rest all the students got less than 80, right? So without percentile, we can't figure out the real meaning. And for example, if I say that, and just like in the GRE, without the percentile, you can't have any idea. There could be a scenario that 165 score in the quant could be in the 90 percentile, could be in the 95th percentile, could be in the 75th percentile, right? Okay, so if a person is getting 90th percentile, so that means the person is above 90% of students who are just sitting for exam. that. And if I want to just have a representation of this, and if I just see a distribution having something like this, any use sort of distribution, a person is getting 15 percentile, so that's mean this person is above the 15% of the data, and on this side will be the remaining 85% of the data. Okay, so how can we find the percentile? There is a formula for this. For example, if I want to find the percentile for some value x, how can I do that? This will be just the number of values below x divided by total number of values into 100. This will just give the percentile, and just take a very simple sort of example. If I have 10 scores, which are 10, 15, 25, 20, 25, 30, 35, 40, 45, 50, and 55. These are 10 scores. So a question asks, what is the percentile score of 35? The question asks, what is the percentile score of 35? How can I do that? See, what are the values below that? Total number of values. 1, 2, 3, 4, and 5. 5 values. What are total values? So 10 values. Multiply this with 100. You will get the value of 30 is at 50th percentile. Okay. So from this, we will just move to the practice session now, and we will solve some example for each of these concepts which we discussed so far. Okay. So now let's solve some example regarding the quartiles, box plots, and percentile to get a better understanding about these concepts. Okay, this is a very interesting question, which is the word problem form of the quartiles. So just solve this question and try to be quick. Okay. So let's discuss this question now. In a company of 100 employees, have different salaries. Tom, who is one amongst the 100 employees, has the lowest salary in the second quartile of the 100 employees. So there are 100 employees. So if you want to divide it into 4 parts, that means 50 on the left side of the median, 50 on the right side of the median, and in either side 25 on each, 25 in this, 25 in this. This is Q1, this is Q2, and this is Q3. This is 25 in this and 25 in this. The question is saying that Tom has the lowest salary in the second quartile of the 100 employees. Second quartile is this, and the first with, because this is 25, so first one will be 26. So right now at the starting, the salary is 26th position. Now let's move further. If the company were to hire 12 new employees, in which 6 of them have salary greater than the salary of each of 100 and 6 have salary less than the salary of each of the 100. So you're adding 6 in each, 6 on the upper extreme and 6 on the lower extreme. So now the total number of values have become how much? 112. That's means 56 on one side of mean, 56 on the other side of mean. So if we divide into if we just take the median of this will be 28 and this will be 28. Again, this will be 28 and this will be 28. So this will be Q1, this is Q2 and this is Q3. Now by adding 6, at first its position is at the 26th number. Now if I add 6 in this, what is the new position? 26 plus 2, which is 32, right? At first this is 26th position, now this is at the 32nd position. Now let's see, in first quartile there are 28 values. Now in second quartile, let's start with 20, 29, 30, 31 and 32. And its value is how much? Value is 32. That's why this is the lowest, fourth lowest value in the second quartile. Which is option C. So that's a quick wrap that at first there are in total 100 employees in which that person is at the lowest first position of the second quartile, which is 26. Now 6 in total 12 joins, and in which 6 are below the lowest and 6 are above the maximum value. So now let's see the new position, that will be 26 plus 6, there will be 32. Now because in total there are 112 employees now, so let's divide into 4 parts. That means 28 in 8 quartile. So 28 in first quartile, next quartile starts with 29, 30, 31 and 32. So that means lowest 4 position in the second quartile. That's why the answer to this is option C. Okay, so now let's move to here. So this is the answer is C. This is a very interesting question, and just try to be quickly solve this. And in this question, what is the resultant interquartile range for the set of unique positive values? Okay, if the value is in the top 50 percentile, so this is the, for example, the median is Q2, lower quartile is Q1, and upper quartile is Q3. Because we're saying if the value in the top 50 percentile are decreased by 3, so that means they are decreasing this thing by 3 and then divided by 5. And while the value in the bottom 50th percentile, the question is saying values in the top 50 percentile. So in this, they are considering the median of this, and in the lower 50%, they are considering this which is the median of lower 50%. So they are in the lower, they are dividing by 5 and reducing by 3. Now the question is saying the actual interquartile range is 48. What is that? That is Q3 minus Q1 is equal to 48. So what is the resultant new interquartile range? So what is that thing? That will be this minus this. That will, if I call this A and this as B. So this will be Q3 minus 3 divided by 5 minus Q1 over 5 minus 3. So this will be, just to take the LCM, this is 5, this is Q3 minus 3 minus Q1 minus 15. So that will be Q3 minus 3 minus Q1 plus 15 divided by 5. So this will be Q3 minus Q1 plus 12 divided by 5. And we know this thing, which is 48. So this will be 48 plus 12 divided by 5, which is 60 divided by 5, and that is equal to 12. That's why the answer to this is option